Welcome to the deep dive.
Okay.
Today, we're diving into FLAVA, which stands for a Foundational Language and Vision Alignment Model. And our source for this deep dive is the research paper, FLAVA, a Foundational Language and Vision Alignment Model by Amanpreet Singh and their team over at Facebook AI Research now.
Right.
Why should you care about FLAVA? Well, imagine an AI that's not just a one-trick pony. It can understand images, like a superpowered image recognition app. It can grasp text like a smarter-than-ever Siri or Alexa. And it can even handle tasks that require both, like answer your questions about a photo.
It's true this model is causing a real stir in the AI community. And what's particularly exciting is that unlike some AI models developed behind closed doors, FLAVA's training data is publicly available.
So no more AI shrouded in mystery. That's refreshing. But before we get ahead of ourselves, let's zoom out for a second. What's the context for all of this?
You're right. Context is key.
I keep hearing this buzzword, foundation models. What's the big deal with them?
Well, foundation models are essentially the bedrock of the AI world right now. Think of them as the Swiss Army knives of intelligence. AIs that can handle a wide range of tasks and serve as the basis for all sorts of applications. The problem is, many current AIs are like specialists. They're fantastic at one thing, like identifying dog breeds in photos. But ask them to understand a text message, and they're lost.
So they're like brilliant artists who can't follow a recipe. Very specialized skills, but limited in their range. And FLAVA is different.
Exactly. FLAVA's approach is unique in that it learns from both single source data, like just images, and paired data, like images with captions. This dual learning approach helps it develop strong skills in both vision and language, making it a true multimodal powerhouse.
So it's like having a personal trainer for image recognition and a language tutor for text comprehension all rolled into one.
A great analogy. But there's more to it. FLAVA also utilizes 3 clever learning techniques: global contrastive loss, masked multimodal modeling, and image-text matching. Each one plays a crucial role in helping FLAVA understand the connection between what it sees and what it reads.
Whoa, hold on. Those sound pretty complex. Can we break those down a bit? Let's start with global contrastive loss. What's going on there?
Imagine FLAVA playing a giant matching game. It's presented with a bunch of images and captions and has to figure out which image goes with which caption. This might sound simple, but by doing this over and over again, FLAVA starts to identify the key visual and textual features that make a good match.
So through this matching game, it learns that a picture of a cat likely matches a caption with the word cat in it. But this isn't just child's play, right?
Exactly. You can see why this is such a breakthrough. It's like teaching a machine to truly understand the connection between what it sees and reads, not just memorize patterns.
Okay, that's global contrastive loss. But what about masked multimodal modeling? That sounds like AI hide and seek.
It does, doesn't it? Imagine playing Guess the Missing Piece with FLAVA. But with both images and text, you give it a picture with part of it hidden and a caption with some words missing. FLAVA then has to use its knowledge of both images and language to fill in the blanks. This forces it to think critically, making predictions based on incomplete data.
So by solving these puzzles, it deepens its understanding of both images and text.
Clever. And what about that last one, image-text matching? Is that similar to the matching game we talked about earlier?
It's similar, but with a twist. In image-text matching, FLAVA is presented with pairs of images and captions and has to determine whether they're a true match or a mismatch. It's like a game of spot the difference for AI, helping it distinguish between genuine connections and random pairings.
So FLAVA is learning to be a discerning judge. Evaluating whether an image and a text truly belong together? That's impressive. But with all these complex learning techniques, I imagine FLAVA must have a pretty intricate internal structure, right? You're absolutely right. FLAVA's brain is made up of separate but interconnected modules called transformers. One for images, one for text, and a third to fuse those two together.
Okay, so it's like having specialized departments that can also collaborate seamlessly. That makes sense. But we've covered a lot of ground already. We've gone from understanding what FLAVA is to how it learns. Before we jump into its performance and applications, I think it's time for us to dive a little deeper into these transformer modules that make up its architecture.
Let's do it. In part 2, we'll explore the nuts and bolts of FLAVA's architecture and how those different modules work together to process information. Welcome back to our deep dive into FLAVA. Before the break, we were teasing apart FLAVA's unique learning process now.
Right.
Let's explore those transformer modules that make up its architecture.
Okay, I'm ready to get into the nuts and bolts. Remind us again what these transformers are. and how they work.
Think of transformers as specialized processing units. Within FLAVA's brain, there's one for images, one for text, and a third to blend the two.
Okay, so let's paint a picture here. Imagine we show FLAV of, an image of, let's say, a cat lounging on a bookshelf. How does its architecture tackle that?
First, the image is fed into the image transformer. It dissects the image, analyzing every tiny detail, like an AI detective searching for clues.
So it's breaking down the image into its core visual components. It's not just seeing a cat, but analyzing the shapes
Colors.
and textures that make up that cat, right?
Exactly. Now let's say there's a caption that goes with this picture. The literary feline surveys its domain. How does FLAVA process that?
That's where the text transformer comes in, right?
Precisely. The text transformer is like an AI linguist, deciphering the nuances of language. It takes the caption and breaks it down into individual words and phrases, analyzing the grammatical structure and meaning of each element.
So we have these two separate but equally brilliant modules, one for images and one for text. But the real magic happens when they join forces, right? What role does that third transformer, the multimodal encoder, play in all this?
You got it. The multimodal encoder is the bridge between the visual and textual worlds. It takes the processed information from both the image and text transformers and integrates them, creating a holistic representation that captures the relationship between the two.
So in our example, the multimodal encoder would link the visual features of the cat and bookshelf from the image with the words literary,
Yeah.
feline, and domain from the caption.
Exactly. This integration allows FLAVA to do some pretty amazing things. For instance, it can now answer questions about the image. You could ask, where's the cat? And FLAVA could accurately respond on the bookshelf.
That's incredible. It's like FLAVA has built its own little understanding of the scene,
Yeah.
merging what it sees with what it reads. It's no longer just processing data. It's starting to understand it.
That's a great way to put it. And remember those learning techniques we talked about before? Global contrastive loss, masked multimodal modeling, and image text matching. Those play a crucial role in teaching FLAVA's architecture to create these powerful representations.
Okay, let's revisit those techniques and see how they fit into this architectural puzzle. We talked about global contrastive loss, the image caption matching game. How does that tie in here?
Global contrastive loss is all about establishing those initial connections between visual and textual information. By playing that matching game, LFL learns to associate specific visual features with their corresponding textual descriptions.
So it's starting to build a vocabulary that links the visual world with the world of language.
Exactly. And then there's masked multimodal modeling, the guess the missing piece game. This is where FLAVA flexes its predictive muscles. By having to fill in the blanks in both images and text, it develops a deeper understanding of both modalities.
It's like if you were learning a new language by watching movies with subtitles. At first, it's all a blur. But eventually, your brain starts making connections between the words you hear and the images you see. FLAVA is doing something similar, but on a much more complex level.
That's a brilliant analogy. And finally, there's image-text matching, which hones FLAVA's ability to spot true relationships between images and text. By constantly evaluating whether image-text pairs are a true match or a mismatch, FLAVA becomes a more discerning judge of visual textual connections.
So FLAVA is training like a detective, analyzing evidence, and making judgments based on the information it gathers. It's becoming a master of both the visual and language domains.
Exactly. And this mastery paves the way for some truly remarkable applications.
Now, I'm really curious. We've talked about the how FLAVA learns, and how its architecture works. But the real question is, how does it perform in the real world? Does it live up to all the hype?
That's the question we'll tackle next. In Part 3, we'll delve into FLAVA's performance across a range of tasks and explore what this means for the future of AI.
Welcome back to the Deep Dive. We've explored the intricacies of FLAVA, from its unique learning process to its complex architecture. Well, the million-dollar question, does it live up to the hype?
Well, that's what we're here to find out. FLAVA was tested on a whopping 35 different tasks, a real gauntlet of challenges, spanning vision, language, and multimodal tasks. And the results, let's just say FLAVA is punching above its weight.
Okay, spill the tea. Give us the highlights. What were some of the specific tasks where FLAVA really shined?
One area where FLAVA truly excelled was natural language understanding. Remember GLUE, that collection of language tasks we mentioned earlier?
Yeah.
FLAVA scored remarkably well on tasks like sentiment analysis, question answering, and textual entailment.
So FLAVA can decipher the mood of a movie review ace a trivia night, and even tell us two sentences logically connect.
Precisely.
That's impressive.
And when it came to multimodal tasks, those that require both visual and linguistic understanding, FLAVA continued to impress. Take VQA, the Visual Question Answering Benchmark. FLAVA showcased its ability to analyze images, understand questions about those images, and generate accurate answers.
It's like having an AI research assistant. I could show it a picture of a historical event and ask, what's happening here? And FLAVA could provide a detailed explanation. That opens up some amazing possibilities for education and research.
Absolutely. But let's not forget about FLAVA's performance in image recognition. While it might not have dethroned models like CLIP in this specific domain, FLAVA still achieved strong results on ImageNet. That massive data set of labeled images.
So even though it's not the ultimate champion of image recognition, it's still a formidable contender. It's like an all-around athlete, excelling in multiple disciplines, rather than specializing in just one.
A perfect analogy. But what makes FLAVA even more remarkable is that it achieved all of this while being trained on a collection of open data sets.
Right, we talked about this earlier. But it's worth emphasizing, FLAVA's commitment to open data not only promotes transparency and ethical AI development, but it also empowers the research community to build upon its success.
Exactly, it fosters collaboration.
Yep.
And accelerates the pace of innovation in the AI field.
So as we wrap up this deep dive, the big question is, what does all of this mean for the future? How might models like FLAVA change the way we interact with technology, access information, and solve problems?
The possibilities are truly mind-boggling. We can envision a world where search engines become even more intuitive, allowing us to search using a combination of images and text. Imagine finding that perfect recipe by snapping a picture of your fridge and asking, what can I make with this?
Or imagine the potential for accessibility. FLAVA could help visually impaired individuals navigate the world by providing detailed descriptions of their surroundings.
And that's just the tip of the iceberg. We can only begin to imagine the innovations that will emerge as AI models like FLAVA continue to evolve.
It's an exciting time to be witnessing the evolution of artificial intelligence. And as we've explored in this deep dive, FLAVA is a testament to the power of innovative learning techniques, a well-designed architecture, and a commitment to open science.
Thank you for joining us on this journey into the fascinating world of FLAVA. We encourage you to explore the full research paper and its supplementary material for more in-depth information. And as always, keep exploring, keep questioning.
Keep learning.